All right. You got 3 of them. We got 3 of them. What's the first one, Maddie? The crust. She's like, I'm going to start somewhere. I'm going to start the crust. Oops, you can't see this, can you? I apologize. There you go. Not like my stylus is working all that well. There you go. The crust. Go. The mantle. And on the inside, the very middle is the boom. There you go. So, if nothing else, I hope that these 3 words have kind of stuck in your brain in the last couple of days. The crust, the mantle, and the core. We're going to look into them and figure out what's going on in them today. But 1, 2, 3, if nothing else, that's stuck in your brain. Questions about that part? As I said, we're going to take notes of this, so we're not going to do a lot with your capture question right now. I want you to pull out your slice of earth paper. Okay? This one, we worked on these conversions together on Monday, that late start day, so our brains were kind of just getting moving when we got in here. Oops, I got a little off. I don't know what happened there. Let's see if I can realign this. Oops, there we go. Before we look at what you did yesterday, I would like to just ask, was there anyone that had questions about the conversion process? I feel like there were a couple of people that mentioned things to me yesterday about that, but I'm just not sure if it was in here or the other class. Any questions about the conversion process? Do you feel like if you were asked to do something like that on a quiz, you could do that? If I gave you a scale and I gave you something to convert, do you think you could set that up? Or no? Yeah? No? Okay. Maybe we'll practice that a little bit tomorrow as well. I don't have any ready to go right now, but I just want to make sure that that's making sense. All right. So yesterday you got a strip of paper, used a ruler and a pencil to sketch out the boundaries, you colored it. In this class, did you guys feel like you got finished with that process? Yeah? Is there anybody saying no or yeah? Yes, you got it? Okay, so what I would like you to do right now is to go over and get your strip of paper. I would like for you to pull it out of your desk. I'm just going to come around and take a look at them real quick and look at them based on that rubric. While I am with other teams, while I'm with other groups, I would like for you at your table to spend a little bit of time going through questions 1 through 4 with your table mates to make sure that you understand those questions. Everybody should have those questions done, and everybody should have a good conversation. Does that make sense to everybody? Okay? Let's do that. All right. So, ladies and gentlemen, we're going to get started again. The kind friends that are sitting at the front table have been so nice to get up and hand you some note sheets, okay? Now, these note sheets, I'll be honest, make me a little bit hungry because they look a little bit like a piece of pie, and I'm thinking back to my... Is the paper edible? It is, I don't think it's toxic.
It is, but it shouldn't.
Thank you, gentlemen. I appreciate it very much. But what is this picture really of? Can anybody tell me? Is it the whole Earth?
No.
It's a slice of Earth, right? It's a slice of the Earth. The reason we're doing this is because as much fun as it would be to have to carry that long sheet of paper around with you all the time, cut it into 3 or 4 pieces so that you could study it and look at it, that doesn't seem very efficient. Also, can you stop being so melodramatic? Can you just
Sorry, my heart beats so bad.
Okay, if you need a moment, then go do your thing.
Okay.
Okay? Otherwise, don't distract the rest of our friends. Sound fair? Okay. I want you to know and understand and love and get this. So we're going to spend time doing some labeling. If you are a color person and you like to label things in color, this would be a fantastic opportunity for some colored pens or borrowing some colored pencils. If that doesn't work for you, like it doesn't matter to your brain, then just one pen or pencil is great. So we're gonna make some labels here. Does anybody see anything on this picture that they can identify? A piece of this that makes sense to them. Yeah, go ahead, Sydney. It is the core. In fact, it's kind of funny. This one and this one are both part of the core. They have two different kind of distinct pieces to them. Yeah. The inner core and the outer core. Yeah. So we're going to go ahead and label those. Let's do that. So we're going to call this one over here. This is the inner core. And the one just above it we'll call the outer core. Okay. Okay, stop throwing things. No. I'm going to make it really clear in my room. And actually, I'm just going to say in all of your life, throwing pencils, it might seem fun. It might seem harmless. I think I've told you this story. I've told some of you this story before. I literally had a student. I'm serious. Okay, just doing what you did. Pencil into the eyeball, emergency room visit. Yes, they still have their vision, but it was not looking very likely for a long time. Okay, so life lesson learned, right? As a teacher and as students, please don't make that something that could potentially, like that is not a risk that's really like worth it, right? Okay. Awesome. I'm glad. Don't do it anymore. All right. Coming back. Inner and outer core, what else do you know? Tell me other things that you recognize that you know that you can tell me about. What are the Earth's 3 layers? The mantle. Where is the mantle? Where is that one located?
The middle.
That's kind of in the middle, right? Between the core and, it's the middle of the 3 layers. It's outside the core, which is in the middle of the Earth, right? So the mantle is this part here. And the mantle has multiple layers as well. We'll kind of get into those a little bit. And then the layer that's on the outside, the top layer of the Earth, the outside layer of the Earth that goes all the way around, right, is the, what is it? The crust. Okay. Now,
what's the little thing on top of it?
What's, the little, what do you think that is? I don't have that in my picture.
Is that pie?
That is the atmosphere, yeah. Let me put in some space and then I'll add a little cloud on mine too. Yeah, I have an older version before we had the cloud. Okay. What is up there? The atmosphere. Now, if this was all the notes were going to be, then that would kind of be silly because we already knew this stuff. So let's add some things to it. What is the atmosphere made of?
Oxygen, CO2.
Oxygen, CO2, nitrogen, right? All these things. All of them are in what form? What phase of matter are they? Choices would be solid, liquid, gas, and plasma. Gas. Okay, there is a little bit of particulate matter in there sometimes, right? There sometimes are ice crystals, but for the most part, the atmosphere is made of gas. Let's keep going with this process. Let's talk about the crust. The crust, is that solid, liquid, gas, or plasma? Solid, yes, it is. The crust is in general a solid. What is the crust made primarily of?
Like rocks and stuff.
Rocks and soil and stuff like that. Now, there are a lot of interesting things that exist in the crust, but for the most part, it's made of rock and made of soil. And we're going to talk about that rock and how it forms and how it kind of goes through cycles. It's pretty neat. We're going to test soil later this year. So we're going to really dig in, pun kind of intended. We're going to kind of dig into the crust later this year, right? But for right now, I just want to make you aware of that. Let's look at a couple of other things going on in the crust. What's this part here? What do you think's this?
Like water.
That's water, yeah. It's like an ocean. The ocean is part of the crust. It's part of that top layer that goes all the way around the earth, okay? Underneath the ocean, there is what they call oceanic crust. And we're going to look at that later this week or maybe next week. I can't remember for sure where it lands in our week. But the oceanic crust is like the bottom. It's the sea floor, okay? And that is made primarily of rock and soil as well. If this is the ocean, what do you think this is over here? Land, yeah. And that's often called continental crust. Okay, so the continental crust makes up the continents, and the continents are the land part of the surface of the earth. Okay, we're going to look later in this week at what happens to the crust and how it moves, perhaps, and things like that. We'll get there soon. But for right now, let's go down further into the earth, into the layers. Tell me about the mantle. What is the mantle made of? You've read a little bit of this.
Like
What? Isn't there like hot in the core?
Okay, we're going to do one step at a time.
Okay.
But Liz, I want you to know that you're on the right track. You're not wrong about what you're saying, okay? And you guys, we've talked about this before. This is a safe and affirming environment, right? For every person. And you know what? It's one of those life lessons that I really believe in, and I don't really take it lightly, okay? Okay? Even if you're friends and you joke around and that's all like good with the two of you, it might not be good with everybody. Okay? Share the love. Come on now. All right. So in the mantle, Liz, what were you saying about the mantle? What do you know about the mantle?
It's not right, but there's lava.
Well, hold on. No. What is lava?
Like the middle is like hot.
Yeah. What? I've asked you this before. What is lava?
It's liquid.
melted rock.
Liquid rock. And what's the mantle made of, friends?
Hot rock.
Hot rock. Yeah. The mantle is made of hot rock. In fact, it's kind of funny because it's mostly solid. But believe it or not, this mostly solid stuff is actually very, very slowly flowing. That's weird. It's slowly. What does it mean to flow? What's that? If you have water that flows, what does that mean? It's moving, right? Sure, yeah. So the mantle is made of hot rock, mostly solid, but not all of it is solid. In fact, you've seen little arrows like this before. You saw some arrows like this in the sun. I don't know if you remember that. Do you remember what that was called in the sun, that zone that had those arrows, those things that moved? Started with a C. Convection, right? There was a convection zone in the sun. Do you remember where the hot stuff would rise and the cool stuff? Remember that whole thing? The same thing that happens in the sun happens in the earth. And it happens in this part of the mantle where you have liquid and solid rock that flows in convection currents. So we're totally going to label that. Those are convection currents. Okay. So that's where the rock is flowing. This thick part of the mantle is called the asthenosphere. ATHENOSPHERE. I'll spell that for you one more time because that's kind of a long word. ATHENOSPHERE. Okay? The asthenosphere is the thickest part of the mantle. Okay? It is made of molten rock, also known as what, Liz? Lava. Okay? And in the asthenosphere, those convection currents move the rock, right? They move that liquid. They cause motion in here, and they also can cause things to move as well other places. Okay? How are we doing? Okay? All right. Let's move down into the core. The outer core is made mostly of, do you know what element? It's made mostly of iron.
Is that where we get our iron?
No, we have iron that's closer to the surface than that. We don't drill down that far.
All right.
Yeah, no. The outer core is made mostly of iron. It is liquid iron. It's a superheated liquid. Ladies, you've got to be quiet, please. Hold on just a moment. What's up?
Does that mean they're diamonds and stuff too?
Yeah.
I don't understand what you're asking. I'm sorry.
It's like the lower you go, there's diamonds.
No, so diamonds are created when carbon is under lots of heat and pressure, right? Yeah. This is, I mean, everything's liquid, right? Everything's melted.
Yeah.
So there's probably a little bit of carbon in there, but it would be liquid carbon, right? It wouldn't be solid in the same way that like gemstones are. Is that what you're asking?
Yeah.
Okay, that's a fair question. Yeah, I needed to kind of process what you were asking so that I could understand where you were going with that. Yeah. So the outer core is made of iron, a superheated liquid, okay? And the inner core, okay, is made of nickel and iron, okay? It's kind of surprising because all the layers, not all, but two of the layers above it are made of really, really hot liquids, right? So you would assume that the inner core would be made of, or would be also what? Liquid or something like that? The trouble is, or the reason that it isn't, is because there's so much pressure. Have you heard the word pressure before? Yeah, pressure. There's so much pressure that even though it's really, really hot in there, the nickel and iron in the inner core is actually solid. Due to incredible amounts of pressure. Okay. We're going to add one more thing to this picture before we move on. I want you to look look at the whole pie piece, or the whole slice of the earth from the beginning to the end. And I want you to talk to your table mates about the amount of pressure and the temperature as you go from the crust to the core. So I want you to talk to your table mates about that. How does it change? Does it stay the same? Does it go up and go back down? Does it go down? Does it go up? What happens to it? Have a conversation at your table real quick.
So, shade drops on Earth is shade. Why would I doubt you? Okay. Stop the jokes now.
All right, let me call you back together. Let's start with temperature. Talk to me about temperature from the crust to the core. Let's see. Angel, what did you guys talk about back there? From the crust to the core, what did you say about the temperature? What do you think happens? Gets hotter, yeah. So let's draw a little arrow for temperature. We'll do temperature in pink, maybe. From the crust to the core, we're going to say that the temperature increases as you go from the crust to the core. I realize that we didn't technically define pressure, so I want to make sure that you understand pressure. Can somebody give me a definition? What do you think pressure means, or what do you think of when you hear the word pressure? Yeah, go ahead.
The amount of mass collapsing inwards and stuff.
Kind of, yeah. So like mass would collapse inward because of pressure, perhaps, right? Yeah, go ahead, Liz. Absolutely. It's like a force like pulling or pushing in on an object, right? Yeah, yeah. So it's like how much it's being pushed is kind of an easy way to think about that. So tell me then, let's see, Hannah, can you tell me, what did you guys say about pressure going from crust to core? What happens to the pressure? Do you guys want to talk real quick? You can.
I just forgot. We did.
What'd you say?
It increased.
It increases. Hopefully it kind of makes sense that it increases, because what's pushing, please stop talking. Please stop talking. Okay? As you go further and further and further in, more and more and more stuff is pushing down on you, right? Yeah. It's the same reason. Has anybody ever traveled to Colorado? Or have you ever traveled to somewhere else where you go up in the mountains? What do you notice when you go to a place that's up higher at a higher altitude?
Your ears pop.
Your ears pop, and what else happens? Like in terms of like when you're running and stuff like that? It's what? It's hard to breathe. Why? Good question. You're further up, right? The air is, there's less, it's thinner, there's less pressure, right? Yeah. So the same thing happens the other way, the further you go into the earth, right? So the reason that in Colorado or in, pick a place that's up in the mountains, the reason that there's a change, the reason that it's harder for us to breathe if we're used to being down here, is because there's less pressure, there's less atmosphere above us, okay? Pushing down on us and making the air more dense. Go further and further and further and further in, there's more and more and more and more and more stuff pushing down on you. Okay? That's why down in the inner core, there is so much pressure, because there's all of the earth on top of it pushing down, right? Pushing and pushing and pushing and pushing. So it means that the pressure increases. as you go in from the core to, or the crust to the core. There's one more that I haven't asked you about yet. And the one that I haven't asked you about yet is the word density. Have you heard of the word density before? Did you study that in middle school maybe, or in junior high, excuse me? What is density? What's that, David? How? I kind of understand what you're saying. Can you give me a little bit more context or explain a little bit more to me about what you mean? Can you give me an example of something that's dense and something that's not dense?
Metal, pretty dense.
As compared to what?
Air.
Sure. That's a very good example. Colin, jeez, I'm trying to teach. I'm trying to have a conversation. And I appreciate you a lot, but it's really distracting me. Okay? Think about metal versus air. Metal is more dense. What makes it more dense?
Pressure.
It's not pressure in this case. Good guess though.
The
mass, there's more mass in a given, if I have a box, right? A 6 by 6 by 6 box of metal versus a 6 by 6 by 6 box of air, there's going to be more metal in that box. Are you with me there? Okay. There's more stuff per volume, per space. Were you going to add something, Beth?
Yeah, I was going to say density is like how tightly packed.
It's not time to go yet.
Molecule, like the molecules. I know.
Say that really loudly and with authority because you're correct.
How tightly packed the molecules of an object are.
I'm going to just say the matter. Is that okay? Just to like keep the scariness out of it? Yeah. How tightly packed matter is. Okay. What do you think happens to the density as you go from the crust to the core?
It goes up because there's more pressure pushing on the atoms, so
they're squished together more, right? Yeah. And there's also some other things that are interesting there. We're going to talk a lot about density in the next few weeks because there's so much to it. But yes, we're going to go ahead and put a line here and say, yes, that density increases as well. Okay. Now, we are going to watch a short video. While I get that video ready, you can wiggle around, but as soon as that video starts, I need you to stop wiggling and stay focused on it. Does that make sense? Okay? The bell's going to ring in just a few minutes, but not quite yet. All right, and 3, 2, 1. Your attention is up here.
Hey everyone, Jacqueline Howard here. Ever wonder what it's like inside our planet? Come with me on a subterranean tour all the way from the rocky crust where we live, through the layer known as the mantle to the wild, half-solid, half-liquid core of the Earth. We'll also be stopping by a newly discovered underground ocean. Let's go! First stop, Earth's crust, the outermost layer where we live. The crust is made up of several elements, from iron to magnesium to sulfur, and its thickness ranges. The continental crust, the stuff found under land, can be up to around 50 miles thick, while the oceanic crust, the stuff found under our oceans, is around 4 miles thick. But let's see what lies below that. Now we're about 50 miles below the surface, at the uppermost region of the mantle. This layer is made up of rock that's rich in oxygen, iron, magnesium, aluminum, and it extends from here all the way down to around 1,800 miles below the surface. The mantle is also where molten rock known as magma can form, the stuff that flows upward during volcanic eruptions, at which point the magma becomes lava. This was pretty much the picture scientists had of the mantle until earlier this year, when a vast, hidden ocean of water was discovered some 400 miles beneath North America. It goes to show that rocks down here have a pretty impressive capacity to store water. But now let's travel a little deeper. You ready? Here we are, 1,800 miles down at the Earth's outer core, which runs all the way down to around 3,000 miles. This is a layer of molten iron that surrounds Earth's inner core.
All right, we'll stop there tomorrow. We'll start there tomorrow. Have a